Hello everyone, this is Jalendran, Assistant Professor working in Electrical and Electronics Engineering Department of Hadiman College of Engineering, Hosur. Happy to meet you on another video. In this video, we are going to discuss about the subject Special Electrical Machines offered for the 7th semester students of EEE Department. The brushless DC motors, shortly called as BLDC motors, are discussed here. The advantages and disadvantages of BLDC motors, the constructional details of BLDC motor with stator and rotor features, comparison of conventional DC motors with BLDC motors, mechanical commutator versus electronic commutator. These are the topics we are going to discuss in this video. Let's go into the slides. The permanent magnet brushless DC motor, shortly called BLDC motor. Why should we go for brushless DC motor? That is discussed under the heading advantages of BLDC motor. The first point is brush maintenance is not required at all, and many problems associated with brushes are eliminated as brushes are not available. Usually, brushes tend to produce radio frequency interferences, and the sparking associated with them is a potential source of ignition in inflammable atmosphere. And all these issues will be avoided in BLDC motors. Second point, rotor is inside the stator, so we are getting more cross-sectional area to have the armature winding. That is a second advantage. Third advantage is the efficiency is likely to be very high compared to a normal commutator motor, that is DC motor, as the brushes and their frictional losses are avoided, are very less, the efficiency gets improved. The absence of commutator and brush gear reduces the motor length, hence higher speeds possible. This is the fourth advantage. And the fifth advantage is removal of commutator reduces the inertia further. Though we have several advantages with the BLDC motor, we have few disadvantages. The shaft position sensing is needed. We need a separate unit for position sensing. Increased complexity in the electronic controller, so it is again a design aspect. And overall cost is also high. So these points should be kept in mind for as disadvantages of BLDC motor. Coming to the constructional details, the construction of modern brushless DC motor is very similar to that of permanent magnet synchronous motor, where we have permanent magnet is present in the rotor. So the armature windings are part of the stator as similar to the PMSM. Rotor is composed of one or more magnets. The windings in a brushless DC motor are similar to those in a polyphase AC motor. Mostly three-phase windings, which is operated in bipolar excitation, will be employed in BLDC motors. The BLDC motors are different from AC synchronous motors in the way of rotor position detection to produce the signals to control the electronic switch. So that is a unique feature we'll have in BLDC motors. Most commonly used position or pole sensor is Hall element or optical sensor. This is an overview of BLDC motor, a cut sectional view we can call otherwise. The outermost part is stator, which is having the stator slots and the tooth, and inside we have a rotor which is having a permanent magnet. This is the simplest view of a BLDC motor cross section. Stator structure. The stator of the brushless permanent magnet DC motor, BLPM DC motor we can say, is made up of silicon steel stampings with slots in its interior surface, and these slots accommodate either a closed or open distributed armature winding, and usually it is closed structure, the slots. The winding is to be wound for a specified number of poles, and mostly it is an even number. And rotor structure. The rotor is made up of forged steel, and rotor accommodates permanent magnet. Number of poles of the rotor will be usually same as that of the stator poles, the count. The rotor shaft carries a rotor position sensor, as we discussed earlier. This position sensor provides information about the position of the shaft at any instant to the controller, which sends suitable signals to the electronic commutator. The electronic commutator and all we will discuss in the working principle of BLDC motor. This is a disassembled view of BLDC motor, which shows the permanent magnet rotor, which will be accommodated inside the stator, and the stator is having windings, which is also shown here. Mostly it is the three-phase winding as we discussed, and Hall elements will also be present there to have the position sensing of the rotor. This is another view of disassembled BLDC motor. Coming to the comparison of conventional and brushless DC motor. In a conventional DC motor, commutation is undertaken by brushes and commutator. But in BLDC motor, there will be no brush and commutator arrangement. So it is done by using semiconductor devices such as transistors, mostly used devices, transistors. And we have a table which compares some 6 features of conventional motors and brushless motors. Taking up the mechanical structure, the field magnets will be present in the stator of a conventional motor, whereas field magnets will be available on the rotor, that is similar to the AC synchronous motor, which is in a BLDC motor. And distinctive features, if you see, quick response and excellent controllability are available in conventional motors, whereas long lasting and easy maintenance are the distinctive features of brushless DC motors. And actually usually no maintenance is required in brushless DC. Winding connections, commonly used connection is ring connection, in its simplest form is delta connection. Coming to the brushless DC, the highest grade motor will have either delta or star connected 3-phase connection. A normal grade motor will have star connected 3-phase winding with grounded neutral point or 4-phase connection. The simplest grade motor will have a 2-phase connection. Coming to the commutation method, mechanical contact between brushes and commutator will be available for commutation and all, whereas in BLDC motor, electronic switching using transistors are provided. Detecting method of rotor's position automatically detected by the brushes, whereas here special elements such as Hall element or optical encoders are required. The reversing method, the direction of rotation, will be done in a conventional motor by a reverse of terminal voltage. In BLDC motor, rearranging the logic sequencer will achieve reversal of rotation. Next slide is about the comparison of mechanical commutator and electronic commutator. Some 10 points are discussed here. In mechanical commutator, The commutator is made up of commutator segments and mica insulation. In electronic commutator, power electronic switching devices are used. In mechanical commutator, brushes are present. They are made up of carbon or graphite. In electronic commutator, brushes are not required and not provided. Mechanical commutator, shaft position sensing is inherent in the arrangements, but in electronic commutator, it requires a separate rotor position sensing. In mechanical commutator, commutator arrangement is available in the rotor. In electronic commutator, commutator arrangement is available in the stator. That is electronic commutator. In mechanical commutator, sliding contact between commutator and brushes will be there. In electronic commutator, there will be no such sliding contacts. Mechanical commutator requires regular maintenance and sparking takes place. An electronic commutator requires less maintenance and there will be no sparking at all. Number of commutator segments are very high in mechanical. Number of switching devices is limited to 6 in electronic commutator. Difficult to control the voltage available across tapping, and the voltage available across armature tapping can be controlled by PWM techniques in the electronic commutator. Highly reliable is the mechanical commutator, whereas reliability depends on switching devices in the electronic commutator. Thank you. Let us meet on another video about BLDC. Have a nice day.